All right, so we're going to talk about cofunctions. So far, we've already talked about reciprocal functions, but cofunctions are kind of different. Cofunctions are based on the idea of complementary angles, which hopefully you'll remember are two angles that add up to 90, which of course I could say much more beautifully. The sum or complementary angles are two angles whose sum is 90, but you get the idea. Two angles that add up to 90. Um, the cofunction identities are sine theta equals 90 minus, oh, whoa, forgot to add cosine goes right here. So sine and cosine are cofunctions, which means that cosine theta is equal to sine 90 minus theta. So whatever the angle is for sine, its complement is the one that goes for cosine. We have cotangent theta equals tangent 90 minus theta, and tangent theta cofunction is cotangent, so 90 minus theta. And then we have cosecant, which I bet you can guess goes with secant. All right, so those are the little identities for cofunctions. We also have the cofunction theorem, which we kind of looked at in class, and it sounds confusing, but the idea is not, the words are. So we're going to write the trig function of an angle is equal to the cofunction of its complement. All right, so that is the cofunction theorem. So let's look at a few examples and some ways you might see things. So if we want to write these little guys in terms of a cofunction, all we have to do is remember what the cofunction is. So the cofunction for tangent is cotangent. And then we need to subtract 90 minus 50. So tangent of 50 would be equal to the cotangent of 40. And I can show you that that's true on Desmos. Pull it up real quick. I should have probably had that pulled up, but you know. All right, I'm going to put it to degrees because we are in degree mode right now. And I'm going to say tangent 50 and cotangent 40. And you can see that those are equal. So the trig function of an angle is equal to its cofunction, the cofunction of its complement. All right, so go ahead and try that one. Number 2, pause the video and then unpause it and check your answer. Okay, welcome back. So secant's cofunction is cosecant, and we want to find its complement. So we subtract from 90. So cosecant of 65 degrees. So these are the answers. It's just a way to rearrange things because later we're going to need to use them in different forms. So cosecant of b, well, its cofunction is sine, and not cosecant, cosine. Its cofunction is sine, and we want to find its complement, so 90 minus beta. Now we can't simplify this, so this is the answer. And similarly, just something to be super aware of, cotangent cofunction is tangent, and we need to find its complement, 90 minus, and then be careful. Make sure that you put the expression that we have in place of the angle in parentheses because we're going to need to distribute that negative. And we're just going to simplify within these parentheses. So tangent of 52 minus 13x, or negative 13x plus 52. So even though this doesn't really look like an answer, it is an answer, and that's how you do it. All right, and then we kind of went over one more type of problem in class. And what we're looking at is this. Cosine and sine are cofunctions. So this expression, cosine 4x plus 19, has to be equal to sine of this, right? So we need to make these both have the same trig function. Right now we have cosine and sine, and we can do this either way. I'm just going to go with changing cosine to sine. If I change cosine to sine, then I'm using the cofunction idea, that its complement will be equal. So we can just interchange those. This side didn't change, but this side, we just changed cosine into its complement, okay, cofunction. So I'm going to simplify that. Sine 1 over, oops, I almost made that same mistake, 4x minus 19. And again, the right-hand side's not changing right now. So sine of 71 minus 4x equals sine of x plus 11. And here's where that little switch in thinking has to happen. You need to be like, okay, so now these are both sine of an angle, and they're equal to each other, which means that this angle and this angle have to be the same. So we can essentially drop the sine and solve the resulting equation. These angles have to be the same because sine of the same angles are congruent. And then we're going to solve that. So x equals 12. And if we want to know what the angles are, we would just substitute in. So we have cosine 4 times 12 plus 19 has to be equal to sine of 12 plus 11. Now, if we did this right, these two angles should be complements. So cosine 48 plus 19 is equal to sine of 23. So this should be 67, and it is. Cosine of 67 equals sine of 23. So cofunctions, complements. And this is the process for figuring that out. So I'm just going to talk through it one more time in case you're like, what in the world did you just do? From here to here, we use the cofunction theorem to change cosine to sine so that our two trig functions were the same. After we did that, we had to remember that sine of a specific angle is always the same. So these two angles have to be congruent. And then we just solve to figure out what x is, and we can substitute it to find our angles. All right, that's it for cofunctions. Have a fabulous day.